Okay, so this is solving log and exponential equations. Method one of the first things we learned was if we have the same base, okay, we can equal the powers, the exponents. So for example, we had, 5x equals 5 square. So since the bases are the same, okay, and the rule was um, a to the u equals a to the v, and that means u equals v. Okay, so the rule was if the bases are the same, then we can equal the powers. So the answer would be 2. X is equal to 2, and that would have been our answer. Okay, now let's say the bases were different. So, let's say we had 4x equals 2 to the third. Okay, so what we needed to do here was we needed to change the base. Okay, so instead of 4x, we could write that as 2 squared raised to the x power equals 2 to the third. And then this becomes 2, because remember, a power raised to a power, you multiply, that becomes 2 to the x equals 2 to the third. And so that becomes 2x equals 3 divided by 2. So x gives us 3 halves. Okay, so that was method one. All right, so we changed we if we can try to change the bases so that they're equal to each other, and then we can apply this rule. Okay, that was method one. Okay, so method two was going from exponential functions to log functions. All right, and then vice versa, going from log functions to exponential functions. Okay, and so, for example, if we had, say, this equation, say log, I don't know why I put a capital there, log of, say, x plus 6 equals 1, right? This is a log equation. And remember, if there is nothing written here, there's automatically a 10 down there. It's base 10. Okay. So as it stands, we're not able to solve this. However, if we change this from a log equation to an exponential one, okay, so if we rewrote this as, um, remember we learned the little phrase, little to the right equals middle. So if we wrote it as 10 to the power of 1 equals x plus 6, then we're able to solve it, okay? So, so again, that was little um, to the right equals middle, right? So the little is the base here. That's the little. To the right is what it's equal to. And then the middle is what's in the parentheses. Okay, so little to the right equals middle. Okay, so now we are able to solve it because now it's in a form we can do it. So this 10 to the 1 is just 10, and then we'll subtract 6 on both sides. Okay, and x gives us 4. Now, the cool thing about this is, we can always plug in our answer to see if it's correct. All right, so let's do that real quick. So let's do a check here. So if we had log, again, this is base 10. I'm putting there for a reason. It's x plus 6. So let's write that down again one more time. So that's log base 10. X is 4, so 4 plus 6 equals 1. So that's going to give us log base 10 of 10. And remember one of the properties, if these are the same, remember this is the power of 1, then the answer would just be that 1. So check. Okay. So anyway, um, so this is going, going from log function to an exponential equation, right? All right, so there's a couple of more here that they give us. But before we do that, let's do a um, couple more examples of this method too. But this one is a little bit an extension. So let me pause here for a second. Okay, so how do we solve this uh, equation here? So last time we talked a little bit about um, combining the properties, right? Or combining them so that they are written in a way so we can solve it. So here we notice that we have a log of base 10 of x plus log of base 10 of x minus 21. So if we look at our log properties, uh, one of the properties we can use is the log base a x y. Rewrite that there. And that's equal to log of base a of x plus log of base a of y. Okay? So again, notice that the right side here matches this part here. So again, as long as the bases are the same, then we're able to apply that rule or that property. So in this case, I'm just going to combine them. Okay? So so I'll have log of base 10, and then these two in the middle, x and x minus 21, will multiply. Okay, and that's equal to 2, right? So now, if you want to simplify this a little bit more, so we have log, and I'll distribute that x to each term. That gives us x squared minus 21x equals 2. And then again, this is a log function. I can't solve it this way, but I can rewrite it as an exponential function. So again, this is a base 10 here. So I can write it as little to the right equals middle. So that would be 10 squared equals x minus 21x. Okay. All right, so 10 squared is going to give us 100. And then we still have x squared minus 21x. So we need to move the 100 to the right. So that's going to give us x squared minus 21x minus 100 equals 0. And then we just factor. Okay, so then our factors are going to be x minus 25, x plus 4 equals 0. And then we set each one to 0. So x gives us 25 and x gives us negative 4. Now we need to plug those in to verify if they do work or not. 25 works, right? Because we have log of 25 and 25 minus 21 is 4. However, if you plug in negative 4, we get log of negative 4. So remember how a graph of a log function works. Okay. Log of x, looks something like that. Okay. So I can put any number in there as long as it's bigger than 0. It cannot be less than 0 if it's just like this. So that means if I plugged in -4 in there, in here, it's not going to work, right? Because -4 is somewhere out here. Okay. -4 is somewhere out here. And the graph doesn't exist there. So it will give me an error. And also, if you plug it into this one, this will be -4 minus 21, which is a -25. So again, it won't work. We can't take a log of a negative number based off of this equation or based off of this log, a particular log function. Okay, so so in this case, then this one we throw out, and our answer would be 25. Okay, so here we have log of base 6 of x plus 4 plus log of base 6 of x plus 3 equals 1. All right, so again, we're going to apply that property. We just hope you remember where we put these together, right? The middles. So it's going to be log of base 6 of x plus 4 times x plus 3. And then this equals 1. Okay. And then we're going to rewrite that from a log function to an exponential function. So little, which is the base here, 6 to the right, which is 1, equals the middle, which is going to be x plus 4 times x plus 3. Okay. All right. So when we multiply this out, we will get x squared plus 7x plus 12, and 6 to the 1 is just 6. And then we're going to subtract 6 on both sides. So that gives us 0 equals x squared plus 7x plus 6. And then we factor. So x plus 1, x plus 6 equals 0. Set them both equal to 0. Okay. So x gives us -1 and x equals -6. Hold on. So both of them not going to work because they're both negative. Well, that's not necessarily the case because now, this moved, right? The log function moved. In this case, this one moved to the left, right? And also this one moved to the left. So anyway, so because now it moved, now we need to consider if it will work, okay? Well, if we plug in -1 in here, so again, if the output is negative, then it's not going to work, okay? If we put -1 in here, well, that's -1 plus 4, which is a +3, so that's going to work. If we put a -1 in here, -1 plus 3 is 2, so that's going to work. Well, what if we put -6? Well, -6 plus 4 is -2, okay, so that's not going to work, all right? And then, of course, here, -6 plus 3, which is -3, again, that's not going to work either, okay? So again, you want to make sure that you check your solution whether both work or only one of them works. So again, in this case, this one is not going to work, and our only solution is x equals -1. So okay, so again, the bases here are going to be 10, right? So we have a base 10 and base 10 here. So this is being subtracted. So the property says, hey, if you have the same basis there, and you have, say, log of base a of x minus log of base a of y, all right, then we can combine them as division. So we have log base of x over y. Okay, so that's the property or the rule that we will be using here. So in this case, we'll have log of base 10, and then we'll divide the 2x and the x minus 3, which is equal to 0. And then we apply the other rule, which is little to the right, or the other method, little to the right equals middle. Okay? All right, so how do we solve this? Well, there's a couple of ways, but probably the easiest way to do this is rewriting this as 10 to the 1 is just 10, and we can write this as a fraction, say 10 over 1, okay? Because again, 10 is the same thing as 10 over 1. Then after that, we can just cross multiply, okay? That's probably the easiest way to do it. So we have 10 times x minus 3, and then we have 1 times 2x. So when we distribute this, we get 10x minus 30 and then 2x. Okay, so again, all right, and then we just combine like terms. So let's move the 2x here and then add the 30 here. All right, so the 2x cancel, the 30s cancel, and we're left with 8x equals 30, and then divide both sides by 8. So x gives us 30 over 8 or 15 over 4. Okay. Now, another way to do this, so we have 10 to the first power, which is 10, 2x over x minus 3, is what we've learned many, many times before. We have an LCD of x minus 3, so we can just multiply both sides by x minus 3. So we'll multiply this by x minus 3, and then multiply this by x minus 3. Then the x minus 3 will go away on this side, and then we'll get x minus 3 times 10 equals 2x. And then we go through the same process and get the same answer. X is equal to 15 over 4. Anyway, so you can either do the cross multiplication as one method, or find the LCD and then multiply both sides by the LCD. Okay. Okay, so here's another method. So again, we have this one says if we have both of the logs are the same, log of base A and log of base A, then we can equal the middle. So m equals n. So for example, if we have this one here, log of base 5 and log of base 5 of, sorry, log of base 5 of x equals log of base 5 of 9, then we can equal the middle. So the answer here would just be x equals 9. Okay. That's pretty straightforward there. Now let's say they kind of change things up and they put a 2 in the front. So let's say they had 2 log of base 5 of x equals log of base 5 of 9 to throw you off. Well, another property we can use is, remember, if there's a number in the front, we can put that as a power and vice versa. If there is a power there, x squared, we can also put that number in the front. So that's all we need to do is put whatever that coefficient is, the number in front of that term, just move it back as a power. So then this would be log of base 5 of x squared equals log of base 5 of 9. Okay? So now this match. This one, the bottom here matches the bottom over here. So then we can just equal the middles, giving us x squared equals 9. All right, and then take the square root. So x gives us plus or minus 3. So remember, there's a power of 2. That means we should have 2 possible solutions. Okay? And so in this case, which one is not going to work? Yeah. Okay, so if we leave it the format here, 2 log of base 5 of x equals log of base 5 of 9. If we plug in negative 3 in here, okay, that's log of a negative 3. So that's not going to work. So our only solution will be x is positive 3. Okay, so again, we play it back in the original form. Okay, so so again, we're gonna do what we've been doing, right? So this one is it's adding two logs. Again, we can do this because all the bases are the same. Okay, so we can combine this as log of base A, and it'll be x times x minus 2. Okay, and then the right side will be log of base A of x plus 4. Okay. And they're like, okay, how do I do this? Well, just apply what we just learned right here, right? If you have the same logs, all you need to do is equal the middles. All right, so in this case, we get x times x minus 21 equals x plus 4. Okay, which it makes it very nice. All right, so then we just distribute the x here, which is x squared minus 21x. Then we have x plus 4. Then subtract x, subtract 4. So subtract x, subtract 4. So we get x squared minus, um, do something here. Oh, let me backtrack here. I put that as a 21, which should have just been a 2. So let me take this out here. My apologies. Okay, so I wrote that as a 21, but that should have just been a 2. So let's do that again real quick. So x times x minus 2 equals x plus 4. There we go. So that should be x squared minus 2x equals x plus 4. Now we can subtract x, subtract 4. All right, so that gives us x squared minus 3x minus 4 equals 0. Okay, much better. All right, so then we can factor this. So that gives us x minus 4. And then x plus 1 equals 0. Set them both equal to 0. So x equals 4 and x equals -1. All right, and then again, we have to plug it in. So 4, it looks like it works. There's 4 here, that's fine. 4 minus 2 is 2, that's fine. 4 plus 4 is 8, that works. But we put a -1 in there, right? So now we change this to a -1. Log of -1 is not going to work. So if it doesn't work with 1, it's not, then we can't do it at all. All right, so that means then we cross that out, and our only solution is 4, which many of you got. Very good. Okay, so let's try one more of these. I'll pause. All right, so in this case, we have ln of 2x minus 3 plus ln of x plus 4 equals ln of 2x squared plus 11. So again, we're going to apply the rule here where we can multiply the middles together. So that gives us ln of 2x minus 3 times x plus 4. Okay? Don't worry about the bracket, it's just another form of parentheses. And then ln of 2x squared plus 11. Okay, so now we have the same base, right? They have base e, so that means we can equal the middles to each other. So we have 2x minus 3 times x plus 4 equals 2x squared plus 11. Okay, and then so we just multiply the 4 out the left side here. When we do that, we get 2x squared plus 5x minus 12 equals 2x squared plus 11. And then we combine our like terms. So minus 2x squared minus 2x squared, that cancels. That gives us 5x minus 12 equals 11. Then we add 12 on both sides. So this 12 cancels, giving us 23. Okay, and then divide both sides by 5. So x is 23 over 5. Okay, and again, we plug it in. It's not going to cause any problems because our output is going to be positive in regards to the middles of each of these ln's. Okay, so as I mentioned, one of the things we can do is we can try to make the bases the same. Method one. So if we, but there's a 3 in the front, so what we need to do is divide both sides by 3, and that gives us 4 raised to the 2x equals 5. But again, if we try to apply method one, it's not going to work because there's no way I can make 4 equal to 5 and 5 equal to 4. I can write 4 as 2 squared, but again, 5 I can write as 5 to the first power, or even 1 over 5 to the negative 1. So that's not going to work. So what we can do is, this is an exponential function. So that means we can rewrite this from an exponential to a log function. So in this case, we have log, and then our base is going to be 4. To the right is 2x, and in the middle is 5. Okay? All right. And then after we rewrite it from a exponential to a log function, it actually becomes really easy because now we just need to get x by itself. So we just divide both sides by 2. Okay, and then there's our answer. All right, so this last method or strategy in solving these log or exponential functions is method 5. So as we go through this, right, one of the first things we learned was, okay, if the bases are the same, then we can equal the powers. Well, in this case, there's no way I can make 2 become 5 and vice versa. All right, so method 1 is not going to work. Okay, method 2 was, hey, let me go back to method 2 in a second here. Let's go to method 3. If I can find it. Here it is. All right. If the logs are the same, then we can equal the middles. Okay. And then method 4 was um, we can rewrite this exponential to a log function. Okay. So can we rewrite this to from an exponential to a log function? It would be really difficult, right? All right. So what do we do? Well, there is this thing called ln. All right, we've talked about that. And so in order to solve this problem, we have to take ln of both sides. Just like the change of basis, what we had discussed, how it neutralizes things if you have different bases. And that's what the ln will do as well. Okay? So so in this case, what we'll do is we're going to take ln on both sides. So we're just going to have a neutralize it so we have an equal playing ground in regards to the basis. So what do I mean by that? So I'm going to take ln here on the left and then ln to the right. Okay? ln on the left and ln over here on the right side. When I do that, all right, now I have these powers. Um, so let me just write this as ln2 to the x plus 1. ln5 is 1 minus 2x. Okay? So notice that I neutralized it, making the basis e, right? And what can we do with the powers? Well, remember one of the properties is we can move the power to a coefficient or move it to the front. So in this case, we get x plus 1, okay, times ln of 2, and then 1 minus 2x times ln of 5. All right, so again, I can take that power and move it to the front. Take that power and move it to the front. Okay, so now this is something I'm able to solve. So then I can multiply or distribute the ln of 2 and then ln of 5. So that becomes x ln of 2 plus 1 times ln of 2 is just ln of 2. 1 times ln of 5 is just ln of 5 minus 2x ln of 5. Okay. All right, so notice we have an x on this side and we have an x on this side, so we need to solve for x. So let's combine all the x's together, and then the ones that don't have x, put them on the other side. Okay? So we're going to add 2x ln of 5 here. Um, add 2x ln of 5 here, then subtract ln of 2, subtract ln of 2. Okay? So the ln of 2's go away, and then the 2x ln of 5 go away on this side. So we get x ln of 2 plus 2x ln of 5, and then ln of 5 minus ln of 2 on the right. Okay. So notice here that we have x here now and x here. So that's a common factor between the two. So we can factor out of x, leaving us with ln of 2 plus 2 ln of 5. And again, this is ln of 5 minus ln of 2. Okay. All right. And then again, we're trying to get x by itself. So now we can just divide both sides by ln of 2 plus 2 ln of 5. ln of 2 plus 2 ln of 5. Okay, so then that goes away on the left side here, and we're just left with x. All right. In the lab work, it's going to ask you sometimes for a decimal answer. So how do we do this? So let's first simplify this, right? So this is a good refresher here. ln of 5 minus ln of 2, they're being subtracted, so that means we can divide the middles. So that'll be ln of 5 over 2. Same thing for this one, but we have a plus here, so that means we can multiply. But before we can do that, we need to change the 2 ln of 5. Because remember, we can't have a number in front of that term. It has to go back as a power. So ln of 5 squared. So that'd be ln of 2 plus ln of 5 squared. So again, here, now we can combine the middles. So that becomes ln of 2 times 5 squared. Okay, so let's simplify this a little bit more. ln of 5 over 2 is the same thing as ln of 2.5. And then 5 squared, that's just 25, and then 2 times 25, which gives us 50. So the bottom there is ln of 50. Okay. All right, so again, that's a multiplication there, another um, a decimal, but this is a decimal here. Okay, so again, this is an acceptable answer just in case the lab doesn't take it, they want it in decimal form. And it's really easy. We just plug this in to the calculator. Hopefully you can see this. Turn it on here first. Okay, and I just type it in the calculator. So I need more space. Oh, that was a little bit crazy. All right, let me do this to the left. Let me pause this for a second. Okay. All right, so if we enter this in the calculator, ln of 2.5 divided by ln of 50, we get a decimal answer of 2.34. Okay. So just in case the lab wants a decimal answer, and that's all you have to do is enter it in there. Okay. All right, so again, the first thing is we look at the bases to see if we can match the base, and in this case, we can't, okay? So what we need to do is we need to use ln in this situation. So we're going to multiply both sides by ln. So ln here, ln here. So this becomes ln of 3 raised to the 1 plus x, and then ln of 7 raised to the 2x minus 1. Then we use the property, if we have a power, we can move it to the front. Okay. So we have ln of 3, and then we have 2x minus 1, ln of 7. Okay. And then now we distribute each term. That's a 1 there. And we get 1 times ln of 3 is just ln of 3 plus x ln of 3. And then we have 2x ln of 7 minus ln of 7 times 1 is still ln of 7. Okay. And then we're going to rearrange our terms. So in this case, the ln of 3, we're going to move to the right, and then 2x ln of 7. Actually, let's go the other way. So I'm going to move the ln of 7 to the left, and then move the x ln of 3 to the right. Okay. So this will give us ln of 3 plus ln of 7, and then 2x ln of 7 minus x ln of 3. Okay. All right. So in this case, again, we're trying to solve for x. So we need to move this 2 to the front as a power. So this becomes x ln of 7 squared minus x ln of 3. Okay. And then notice that we have an x on both of these terms, so we can factor out an ln, I'm sorry, a 7, an x, and so that'll be ln of 7 squared minus ln of 3. Okay. All right, so that's what we get on the right side, and then we just bring this down. Okay. All right, and then the next step is we're going to divide both sides because again, we want to get x by itself. So we're going to divide this by ln of 7 squared minus ln of 3, and then ln of 7 squared minus ln of 3. So that cancels there. So that leaves us with x, and I'm going to now combine this. So we have ln 3, ln 7, so I can multiply those as 3 times 7. And then down here we have 7 squared, which is 49, right? So ln of 49. So I can now subtract these. I'm sorry, divide those. So we'll have ln of 49 divided by 3. Okay. So we'll have ln 3 times 7 is 21. And then 49 divided by 3. Let's see here. Will give us 16.3 repeating. So this is 16.3 repeating. Okay. So if we put that in the calculator, we will get, let me pause here for a second. Okay, so here, just to make sure that in the end, so again, we divide both sides by the ln of 7 squared minus ln of 3. So we get ln of 3 plus ln of 7 divided by ln of 7 squared minus ln of 3. And then the 7 squared becomes ln 49. And then we can combine these because these are being added, so we can multiply them as 3 times 7, which gives us ln of 21. And then we have the 49 minus ln of 3. We can divide those as 49 over 3. And I just left that in that form because the thing with math, as you know, is the more you round at the beginning, the further you are going to be from the exact answer. So I just left it in that form. So we just take ln of 21 divided by ln of 49 over 3, and we get 1.089997. So, all right, let me pause this.